Algebra 1, Chapter 5.4, we're going to solve compound inequalities. So probably before we start with, solving them, we got to talk about what is a compound inequality. Well, guys, a compound inequality contains at least two inequalities that are separated by the words and, or. Okay? And each one of these ands, ors means something different. When I think of and, I think of having to be more than something, right? Like, I have to be, or to be in this class, you would have taken pre-algebra and be in 9th grade. Right? So you have to have done both or have both in common to do this. That's an and. An or would be, well, you have to have taken pre-algebra, or you can just be in 9th grade to be in this class. So in that case, you can be either one of those and be fine. So, and, only true if both inequalities are true. Interesting. Because now remember, we're talking about inequalities, we're talking about ranges of values. We are talking about where they overlap. And that's all part of this thing here, is that we got the intersection of their two graphs. Okay, and we're going to do some examples of this. So the intersection, it's an and. They have to be where they both are at the exact same time. Not one or the other. An or is true if at least one of the inequalities happens to be true. This is called a union. That doesn't seem right. Let me check on that. Okay, union is the right word. I just got it mixed up. So when I think of the union, guys, maybe think of like marriage, right? And kind of think of the idea that you're bringing two things together. So you got his and hers type stuff, and so therefore they can be now in both places, but yet still together as an answer. Okay? I don't know if that kind of helped out or not, but you can be in one inequality true, but not in the other. For an or statement, it's fine. But an and statement, it has to be where they intersect, where they overlap, where they both have in common. So, what we want to do is I want to solve and graph the intersection. So these ones are ands. As you can see by the first example, there is the and word in it. So, where is y minus 3 greater than or equal to negative 11, and y minus 3 is less than or equal to negative 8? Here's the cool thing. I am going to solve them individually. But what I'm going to do for sure is bring down the word and every single time. And I need to see that every single time, guys. How would I solve for y in the first inequality? Next. Add 3 to both sides. And if I add 3 to both sides, it cancels the 3's on the left. It's y is greater than or equal to? Negative 8. Everybody okay with that? And, wait a minute, to get y by itself on the right side, I also can add 3. And if I add 3, it's y is less than or equal to negative 5. Here's the cool thing. This is an and. We need to figure out where do they overlap. What makes it true for both? And so when I go to make my graph, I'm going to look at my points, negative 8 and negative 5. Which one goes where? Which one goes on the left? Which one goes on the left, guys? Negative 8 or negative 5? Negative 8. Then it's negative 5. Are these open, closed, both the same, one different? Both the same, and they're both closed dots. Okay. Now, I'll even do this once. I'll change colors, okay? So the one on the left with the -8, I'll make red. And the other one I'll make purple. Excuse me.
God bless you.
Thank you. So, where would 0 be in the large scheme of all of this? On the far right, right? So somewhere way over here is 0. So can I use 0 for both of these as a check? Yes. So, up here, if I put 0 in for y, is 0 greater than or equal to -8?
Yeah.
Yes. So therefore, would you guys agree that I would have to shade towards 0?
Yeah.
Yes? Okay. Now, I need to say, okay, here are my options. When I check that same exact point of 0 with the y is less than or equal to -5, I'm either going to shade the left side, right? Or I'll shade the right side. It's only two options. If I happen to shade to the left, they'll be overlapping in one place. If I shade to the right, they'll overlap somewhere else. So the question is 0 less than or equal to -5? And I'm seeing heads say no. So therefore, I need to shade to the left. Now, by doing two different colors here, can you see where they overlap?
Yeah.
They seem to overlap. And I'll change colors again. Here. Right? They overlap from -8 to -5. Is -8 included in the solution? Is it covered by both? Yes, it's included in the red line, but the purple line goes through it as well, so therefore it's included. What about -5? Yes. So technically, guys, -8 to -5 is where all of your solutions, including the endpoints. Moving on to the second example. This is a compound inequality, but it has no ands or ors. The process is the exact same. Whatever I have to do to get that variable r, which is in the middle, whatever I do to the middle, I have to do to the ends, or the sides. So how can I make r plus 7 to be r?
Subtract 7.
Subtract 7. What I do to the middle, I do to the ends. And so r is in the middle with the greater than or equal to. There's a less than or equal to, and then a less than on the other side. What is 6 minus 7?
-1.
-1. What's 10 minus 7? 3. Hey, did we graph these already or no? Because I think I have some endpoints at -1 and 3. Are they both open, both closed, or one of each? One of each. -1?
Close.
Closed. 3? Open. Ooh. Would you guys agree? 0 is in the middle there. So in that case, can I check 0? If I go back to the original problem, 0 minus 7, right? Or plus. No, it's plus. 0 plus 7 is what? 7. Is 7 bigger than 6, but still less than 10? So guess where I shade? I shade right down the middle. Hey, wait a minute. We probably should check the outsides as well, huh?
Yeah.
So, something like -2, right? -2 is right there. Is -2 plus 7? What's -2 plus 7? It's 5. Is 5 greater than or equal to 6? No, it already doesn't work. So I don't have to keep going. I don't shade that side. What about going to the other side of 3? So something like 5. What's 5 plus 7? Is 12 greater than 6 or equal to 6? Yes, but it has to also fall between less than 10. Is 12 less than 10? No. Satisfies one end, but doesn't satisfy the other, so therefore, it's not shaded. Our answer only lies between -1 and 3, including -1. Cool stuff? Mm-hmm. Not so bad. What you do to the middle, you do to the end. So then we can go with a kind of a maybe real life type of situation. It says that a company is manufacturing an action figure, not a Barbie, an action figure, that must be at least 11.4 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure can be. Let's use T for tall, right? Or what do you want to use? T for tall or H for height? It doesn't matter. Let's use H. H equals the height. Okay. So then what can I do here? It says that H needs to be what? Must be at least 11.2. What does that mean? Can it be equal to 11.2? Okay. So 11.2. It can be equal to it, so I'll put a little line underneath. But which way should the inequality symbol go?
Greater than.
Should be a greater than?
Yeah.
So H has to be bigger than or equal to 11.2? And, right? And H has to be what?
Less than or equal to that.
Less than or equal to 11.4. There's your compound inequality. Hey, wait a minute. Could I write this as one compound inequality?
Yeah.
If I have to be bigger than something but yet less than something else, can I go back to that last example I did and write just one compound inequality? I don't have to use an and or an or. What would that look like? 11.4. 11.2 is less than or equal to H, which is true. But then H is also less than or equal to 11.4. When you see it in this form, where will you shade? Always? In the middle. So when we go to graph it, like it asks us to do, I will put 11.2, 11.4. Both circles will be closed, and you will shade in the middle. Now this works as a real life type of problem because pretty much everything that is made has to be made within a certain tolerance, right? You don't want to get an action figure or a toy or a chair or a desk that's not uniform in size. But we all know that if we took everyone's desk right now and we probably measured it, there could be some very slight variations in their sizes. Okay? It's because the machines are different. A different machine will be slightly different from another machine. After a while, the machine needs to be fixed or recalibrated to make it all back together again, the right size. So this is definitely a real life type of situation. You will have tolerances that are within ranges, and this is what they would have to show. Okay? Very cool. Now let's talk about some mores. So solve a union. Graph the union. Ands, guys, go towards each other. Ors go away. Again, solve these separately, keeping or going where it needs to, and then graph it separately on the same number line. I'll give you guys a chance to try this first one on your own. Okay, what's my first step on the first one? Fritz? Subtract 1 on both sides. And so you get A is less than 3. Or, now the other side is something different. Instead of subtracting 1 from both sides, I'm going to add 1 to both sides. And now A is greater than or equal to 4. This is really not too bad, is it? And here's the thing, guys. Yes, we're doing a couple of slightly easy ones here. Obviously, the next one, as you can see, we're going to start adding a couple of those multi-step inequalities in there. So just be careful. Watch your steps. You guys know how to handle. You know when to flip signs, when not to flip signs. So be careful on all of these. So when I go to graph this, it goes 3 and 4. Yes? 3 is open or close? Open. 4 is closed. And I can, guys, again, test 0. Always test something. Don't just take my word that ors should go away from each other. Test 0. Is 0 less than 3? Yes. So I shade towards 0, or the side that has 0. Going between 3 and 4, maybe 3.5, right? Is 3.5 less than 3? No. Wait a minute. Is 3.5 greater than or equal to 4? No. So actually, it doesn't even work for either one of these. So even this point at 4, for this A is greater than or equal to 4, I wouldn't even shade on this side. That means I have to shade on the other. But we could test it with 5, or you could test it with 0. 0 is also not greater than or equal to 4. So I'm going to shade this way. And there's your graph. I'm going to give you guys 1 minute to solve and graph the next one. Okay. Let's think this through. It's no problem. The first part, do I even have to do anything? No. So, guess what? I'm going to bring it along for the ride like you guys do. You guys have to go along for the ride all the time. So, x is less than or equal to 9, or, Kathy?
You could subtract 2 from both.
Subtract 2 first, yes, from both sides. And so you get 4x is less than 8. And then, Carson, what's next?
Divide 4.
Divide by 4. And so, x is less than or equal to 9, still bringing it along for the ride, but now x is, do I flip the sign, guys?
No.
No, okay. Is less than 4. And then if I graph this, 4 and 9, 4 goes to the left, 9 goes on the right.
Yeah.
Oh, it is 2. I am sorry. Good catch, guys. 2, 2, okay, 2 and 9. 2 is open, 9 is closed. So you guys got to be careful with this. Guys, because it's an OR statement, if you've done it correctly, it should go away from each other, but I would never trust someone's work, so I'm going to check it myself. 0 is over here. Is, checking it on the 2 side, this is the 2 one, is 0 less than 2? Yes. So I shade that way. And then I go over here. Is 0 less than or equal to 9? Yes. Uh-oh. So wait a minute. I'll change colors so we can see that. That means that it's that side, right? Well, isn't that funny? I've been saying that ORs should go away from each other, right? This problem did not. Is that necessarily wrong? No. But if you think about this, actually, could I write this as one inequality answer? What would the one inequality answer be for something like this? Max, what do you think?
When you have your 2 on the left and you have 2 is greater than x, but then less than or equal to 9.
So you want to do this?
Yeah.
Okay, let's think of this, guys. If I wrote this, which is 2 is less than x, which is less than or equal to 9, that means x only exists between 2 and 9.
Oh.
Right? Because x has to be bigger than 2?
Yeah.
That's not what this says, does it? 2 is bigger than x. How can I write the inequality for this solution? Guys, remember what this or means. What does or mean? It can be here or there, right? So I can be the purple shaded region, yes?
Yes.
Or I can be the red shaded region. But wait a minute, doesn't the red shaded region include the purple? Interesting. Now wait, so that means, shouldn't the answer just be x is less than or equal to 9? Because all solutions fall within that range? What are you thinking?
Since 2 is like not part of the shaded region, so that it wouldn't be an answer.
Okay, so Matt's saying 2 up here, guys, is an open circle, yeah?
Yeah.
Because it's not included here. So should we also down here state that maybe x can't equal 2? Can't. Put a little slash through it. Should we be stating that? Here's the question. Is 2 included with the x less than or equal to 9? So technically, in the first group, 2 is included. 2 is not included in this one. So if I'm an either or type of situation, is 2 in or out? It's in. So actually, you would not put that there. The answer is just x is less than or equal to 9. It's tricky sometimes, guys. They overlap. They are overlapping in an if or an or statement. So here or there type of situation. So therefore, the one that encompasses the most is your answer, which happens to be the x is less than or equal to 9. Your homework is worksheet 5.4. Have a great day.